item 4 that Emily put there, what we wanted to talk about is how do we create a vocabulary for synthesis, and what we're talking about in this case is an Arctic carbon budget. It is the example of a synthesis that we had chosen, that IARPC has chosen as part of their 5-year plan, and to look at. And so what the phone call was really about is trying to understand what the barriers are for researchers in conducting a synthesis. And again, this one's carbon. And so what I've done is I've tried to invite people, just a few folks from different areas. And it doesn't, it's not completely inclusive. It's just sort of a broad stroke at looking at different areas. And the different areas in this case are the folks, the observational folks, those people who are going out making measurements. There is the modeling, and I'm not sure I want to call it completely the modeling. Wen and Chris, really much of what they do is develop algorithms. And so we can call that algorithms modeling. And then there are the data folk, people like Peter is one case, and Matt Jones and Mark Schilderhauser from NCES, who is the Arctic Data Center. And so if we ask, what is it that's preventing us from, well, sort of working together in a sense, and what are the bottlenecks for us for completing or conducting a synthesis? And I don't just mean, let's say, units. I don't mean that, well, maybe the oceanographers are going out and making measurements in 1 unit, and the land atmosphere people are doing it in different units for carbon, or that might be a problem. And I think that is a problem to some extent, but we're also focusing on different parts of carbon. The land atmosphere people are focusing on methane and CO2, and the people who are looking at the delivery of nutrients to the ocean are looking at DIN and DOC. And so they're looking at different, well, essentially different molecules, different compounds. And so is that what's holding us up, is the fact that we're looking at really across these fields where we're looking at different species. And maybe that's part of the problem. And then there's other problems, which include, in many cases, what's reported to a data center, maybe a measurement in some form, but then what's reported to the data center is some derivative of that measurement. And so somebody has to make some decision about what is that derivative that I'm going to provide to the data center? And if I'm going to provide a derivative product, do I have software that comes along with that? And so what I wanted to do is to focus on what are the bottlenecks that are holding us up for doing synthesis. And that means both within the measurements area and within the data areas and within the algorithm areas, and then across the groups. And really what I wanted to try and do is have some discussion today about that. And so I've invited 6 of you or so to give us your perspectives, and then maybe a very short intro from each, and then we could begin a discussion on if we were going to conduct a synthesis for the Arctic for carbon, how would we do it as a group, knowing who we are each individually and what aspects of the problem we're working on. I did get a call. Let's see what Matt Jones says. Okay, Matt.
Matt is on the line.
Matt's on the line. Okay.
Yes.
Yeah.
And
So-
so is Mark as well. Mark just joined us.
Okay, perfect. So maybe what we'll do next is have everybody introduce themselves and what aspect of working with carbon that your research is focused on, and then we can move into a discussion area. So Christina, you want to start as the observer first in that list of observers?
Sure, I can do that. Observer, so I'm actually not really a data producer myself. I am doing synthesis mostly, which means I use other people's data. So I'm aware of all the inconsistencies that may exist among data sets. And I've been struggling with that. There are solutions. Some just will not be included, some data sets, because there are all these inconsistencies. And what we often come up with is, in the end, a recommendation piece. It's either a protocol or even a paper that deals with the inconsistencies and writes about or describes better approaches.
When you say inconsistencies, what do you mean by inconsistencies?
By what people measure, metadata in particular. And that could just be, let's say, for the incubations that I have been synthesizing, they don't provide a depth profile or at which depth people take the full course. Something very simple that seems simple, but it's still sometimes not provided. Or no carbon number, just flux. And if you don't have the original carbon concentration in the soil, you not do all the calculations you would like to do. Very simple things sometimes.
So but you're primarily on CO2, methane,
Yeah.
and soil carbon.
Yes, that's right.
Okay. Do we want to go with Jim? Jim, I think you're off. You're muted.
Can't hear me.
I can hear you now.
Good. Yeah, in terms of my background, broadly speaking, I am, I study watershed, ocean interactions, in particular, sort of the sort of movement of water and waterborne materials off the land and landscape into coastal ocean systems, and ultimately sort of how changes and variability in those inputs affects ocean systems. But in terms of I guess today's discussion, I think a lot about the sort of carbon transport from land into the ocean in its various forms. And one of the things that when but I also work at a wide variety of scales, everything from sort of Pan-Arctic synthesis activities to headwater stream really detailed studies. And so one of the things that I thought about first when I heard about this little session was that what strikes me often is that we often use the same words but mean very different things. And just one example of that, I'm working closer right now with someone who does a lot of process work in rivers and streams and estuaries, and when she says the word flux, she automatically is thinking of and talking about fluxes in and out of the sediments and of, say, CO2 or nitrogen or other things, and fluxes from the say of N2 or CO2 from the water to the atmosphere. When I say fluxes, I'm talking about lateral movement of materials downstream, right? And so even when we're working closely together, we often have to remind each other which type of flux, what we mean. And so I think the specificity of language within our sort of subdisciplines, we think we're being specific, but we're not. And that translates into metadata and everything else, right? We're using the words just how we always use them, but they're vague when it comes, or they mean something completely different to another user. So that's, in terms of vocabularies, I think that's sort of an interesting and certainly a surmountable problem, maybe in terms of things like, even in terms of, I can imagine a situation where if you put in a search term, maybe automatically other similar terms would be sort of folded in there, even though you didn't specify them, that would create those links, knowing that these crossover issues and questions.
All right. Why don't we, Chris, you want to say something?
Sure. Can everyone hear me?
Yeah.
Great. Yeah, I'm Chris Mattman. So yeah, my research, I typically work with scientists both at USC and JPL, and in situations like this where you're interested in doing a particular study, in this case related to carbon and things like that. One of the things I've been working on recently is building tools necessary to do the things that you would normally do by hand automatically in the form of collecting research data for that study. So imagine that to do this particular study in this group, you had to visit a bunch of websites and see what other researchers are doing, with carbon, to not only look at their data, but look at textual descriptions of what it's talking about, to find common and similar publications, for that data, and to read those publications and then understand various measurements that people are talking about, what instrumentation they're using, and all of the other things that I've already heard discussed a little bit. The tools that I'm working on and that I'm funded on from Mark right now and that I've been building for the last decade are tools that crawl the web, that scrape data from these sites, not just HTML data, but publications like PDF files and Word documents, all the way to multimedia data and so forth, and extract information from them and take that extracted information and make it available for search, interaction, visual analytics, seeing, what they're talking about and things like that. So all the work that you normally do by hand, you do automatically. And so if that capability is useful for this team, and, I think it might be, but, I need to hear a lot more, and I'm going to do a lot of listening. It could be something to help, as we progress here, in this group and in this particular study, to help collect ancillary information and to synthesize it that might make it useful to future endeavors here. So that's where I'll leave it.
Okay. So Wen is not on, or is she?
She is on. Wen, can you hear us?
Yes. Hi,
Great.
Mark. This is Wen.
Hi. So Wen, do you have you heard what's been the discussions?
Yes. May I introduce myself?
Mm-hmm. Yeah, and what part of, in the sense of this discussion of carbon do you focus on in the sense of data?
Okay.
Where you come in to the picture.
Okay. Hi, everyone. My name is Wen Li. I'm working at Arizona State University. In the past years, I have been working on developing large-scale web crawler, similar to what Chris does. But my main focus is to discover the distributed geospatial data that are widely shared on the web to support various kind of applications, such as the carbon-related work. For instance, I have developed a Polar Hub, which is a large-scale web crawler which has the ability to crawl both the deep and the surface web to discover the distributed data resources. I can share the online link of Polar Hub to all of you. It's open to public. And so far, Polar Hub has found nearly 80,000 data sets, and it's about 1.4 million unique data layers distributed in 95 countries. So we have collected automatically a large number of data sets that contains various kind of themes or subjects. In terms of carbon, what we can do is trying to make the semantic understanding of the data we found and to see which set of the data that can be best used to support different carbon-based applications. One of the work that I have been working on recently is trying to make the semantic understanding based on ontology and based on advanced search technique. And another area that I'm also working on is trying to develop a comprehensive measure for data quality, because the good data is certainly can be used to support the better science. And as we may know that lack of the good metadata is always a big obstacle in advanced understanding and the semantic interoperability of data provided by distributed data providers. So that's one of the work that I'm working on. So mainly on data collection, discovery and search, and semantic ontology-based semantic understanding of the data, and as well as data quality checking for like different science use cases.
Okay. Do we want to move now on to the actual data itself? Matt, you want to say something?
Yeah, thanks, Mark. So I'm Matt Jones. I'm the PI on the Arctic Data Center for the National Science Foundation, and we're the primary archive for data that's funded under the Arctic program at NSF, and we also house other Arctic data on a sort of on a as able basis. Whenever we're able, we bring in other relevant thematic data. I don't know who's talking.
There's some typing.
Yeah, it would be really helpful if you muted. Thank you.
That was me. I'm really sorry. I'm taking notes. I forgot it.
No problem. Thanks, Emily. So yeah, I'm lead the Arctic Data Center, and we're collecting data that I think is super relevant to this carbon synthesis. We have a number of data sets, which we talked about in a previous talk. We also run some synthesis activities, and we're starting one up with Ted Schur on permafrost and carbon, and trying to bring together some of that. So there will be both synthesis and data aggregation activities at the Arctic Data Center. But I also wanted to mention other projects that kind of fit in to this general theme, which is that the Arctic Data Center is embedded where I am here in UC Santa Barbara at NCEAS, the National Center for Ecological Analysis and Synthesis. And we spend a lot of time over the last 20 years running over 500 syntheses in different parts of ecology and environmental science and collating data. And so over the years, we've really gained an appreciation for just how difficult the data management and data wrangling parts of synthesis are. That a lot of the work in synthesis is really in collating and integrating and harmonizing the data sources that you want to use in a larger scale analysis. And so we've been focused for a number of years on both making access to data easier, but also trying to improve the situation with respect to understanding the semantics associated with data and how different data sources collected by different individuals can in fact be used together in a synthetic activity. So I'll give one example of that, which was as part of our Data One project, where we're trying to federate data repositories. We were looking at carbon modeling projects, and Debbie Hunsiger and Christopher Schwamm from the NIST program, which is a model intercomparison project, they were trying to compare the outputs of 20 or so different terrestrial carbon models and try to understand why those models differed so starkly in their predictions of future carbon budgets. And in the process of running that whole intercomparison, it became very obvious that to them that the big issue was one of semantics and not having a shared semantic. So I want to sort of mirror what Jim said about vocabularies, because it became very clear early on that things like net ecosystem exchange, which is purportedly a pretty simple concept that most people probably understand if you're in carbon modeling, is actually a whole suite of concepts, and different modelers define it differently. So some modelers include the impacts of, for example, fire in net ecosystem exchange, and others do not. And there are a number of axes like that. There are a number of assumptions about what goes into each of these different concepts that the modelers were making, and those assumptions were in turn driving a lot of the differences in predictions behind these. And so in working with Debbie Hunsinger and the other researchers there, it quickly became apparent that it would be really beneficial to be able to develop a very strongly controlled vocabulary that allows each modeler to very precisely explain what their version of net ecosystem exchange really represents in terms of what components are included, excluded, et cetera. And so we've been working, so Mark Schildauer, who I think is on the call, and I have been working for a number of years in trying to build up vocabularies and ontologies that let people precisely represent measurement semantics. So in particular, to differentiate the subtle nuances between, say, two different measures of carbon flux or two different model outputs, and be able to really show those. And so we've been building a vocabulary called EXO, which is the ecosystem ontology. It's an extension of a lot of the other ontology work that's been going on in the community, and really trying to capture many of these subtle differences among the measurements that are being taken, and then apply those to the data that are present, not just in the Arctic Data Center, but all the other data repositories that we operate.
Okay. Let's
Thanks.
get Mark, and then we'll open up the discussion. So Mark, you want to say a word or two?
Sure. I think Matt just laid down a real good baseline of where our interests and challenges have been over the past few years. I'm also, I'm Mark Schildauer. I'm also at the National Center for Ecological Analysis and Synthesis in Santa Barbara. I'm sorry I'm a little late for this meeting, but I'm actually at something called ESIP, which is the Earth Science Information Partners meeting in Bloomington, Indiana, where there are a lot of information managers and computer scientists who are wrestling with these exact issues about data access and interoperability. And in fact, I and my colleague Margaret O'Brien presented on the EXO, or ecosystems ontology, that Matt just mentioned. One of the exciting things that I'm finding out at this ESIP meeting is that there are a lot of concern here among people discussing the importance of developing standard vocabularies. So we're having a lot of interactions with communities who are developing vocabularies and are very concerned about those vocabularies complementing and being interoperable with one another. So specifically, we're having strong interactions here with something called the environment ontology, which is part of a major group of ontology vocabulary developers called the OBO Foundry. There's also a lot of people here from the NSIDC who have been developing vocabularies, for instance, for sea ice. And then the earth science community in general has been developing a vocabulary called SWEET. And we're all meeting up actually later this afternoon to discuss how we can sort of at least get our vocabularies interoperating, to continue to move the effort forward, and both harmonize and sort of divide and conquer the various specialized areas of concern. So recognizing that, I am also a co-PI on the Arctic Data Center. We had started on behalf of the Data One project, where I'm one of the co-leads of the semantics working group on Data One. We were focusing on the carbon cycling issues in general. And then when it turned out that the synthesis working group led by Ted Schur, that's going to be happening through the sponsorship of the Arctic Data Center, focused on permafrost thaw and carbon cycling, it gives us a great opportunity to focus specifically on the development of a carbon cycling vocabulary suitable for the purposes of Arctic carbon cycling integration efforts. So the timing on this is just outstanding in terms of all of these different activities converging, and the importance that I think here at ESIP that we have a lot of certainty that when we develop this vocabulary, it's going to be done using really appropriate web compliant technologies. So those technologies, they're basically W3C recommendations for the vocabulary and syntax you should use in constructing the vocabularies, and how you need to make those available through the web for access and understanding. So those are all the very positive aspects of I think this vocabulary effort. I'm just totally stoked about it.
So maybe I'll pose the problem, because Matt and and Mark, you've mentioned ontologies a few times. And so if you're a person like Jim, and maybe Jim or Christina can say something, they make measurements. What does it mean to them? So if we want to conduct a synthesis and we want to bring people together, and I know I didn't bring any land surface people here, so there's only 1 hour to do all this, and but Jim does some modeling, analysis, and so does Christina. They go out, they make measurements. What is their real relationship to an ontology? What does it mean? So if you're working with them and you say, oh, listen, we want to do a synthesis, you're going to go out and measure for 2 years, it would make our lives much easier if. So Jim or someone, or Christina, maybe chime in on that, or Matt or Mark.
You know, I think we understand exactly what you're getting at, Mark. It's the problem that we encounter every day at a synthesis center when two researchers bring their data sets together, and we then have to examine those data sets and determine how or whether they can be integrated, you know, in some sort of a synthesis type of analysis. So for that reason, our focus on this knowledge modeling and development, we call it ontologies because actually strictly we are using these kind of formal logical conventions to make those vocabularies kind of turbocharged vocabularies. But as far as a scientist is concerned, it can just be called a vocabulary. And our focus on those vocabularies has specifically been to just go right to the measurements. So what we'd ideally like is for the scientists, when they come in with their data, right now they've probably given the names of the measurements their own little idiosyncratic names. They potentially are assuming units. Hopefully they can tell us what those units are. But it's very possible that they're using different labels and different definitions for the same thing, or they're using very similar sounding names for different things. This is what vocabularies can clarify by them being able to point to a term in a vocabulary and say, that's what this measurement is. Or they can look at a list of measurements and say, I don't see my measurement there. And then we elicit a description and definition, and it becomes available for them to say, this is what I measured, and for the next scientist to similarly do so.
So Peter, you've thought about this a lot.
Sorry, I wanted to jump in quickly. Is that all right?
Sure. Sure.
Yeah, so I was just going to say, as one of these people that goes out and collects data, that I'm not sure exactly what interoperability means, but I'm pretty sure that what we can't do easily is change our vocabularies, because there's a long history within disciplines and subdisciplines and the way that words are used and whole, you know, vocabularies are used within that is tied to that history of literature that makes it difficult to toss that out. Which means I think the way forward isn't to convince everyone to use the same vocabularies, but rather to make these cross links and make it understood at the point that data goes into these repositories, that X means X in this discipline means Y in this discipline, or this is how they're different, right?
That capability is completely enabled. When we're talking about vocabulary construction, it's not trying to constrain, it's to simply document more clearly what someone means when they use a particular term or label.
But yeah, that what you were talking about, Jim, of being able to annotate, you know, use your term that you use for your vocabulary and then map that to other vocabularies is exactly what we're proposing needs to be done. That people, you know, continue to use their domain specific and, you know, semi-ambiguous English language terminology, because that's the way they communicate, but map that onto a vocabulary that has the bigger space in mind, so that you can tell the differences between one person's net ecosystem exchange and the other person's net ecosystem exchange, which are subtly different.
Yeah, that sounds great. That sounds like a good way.
So let me get to Peter here. Peter's on.
Yeah, so I'll just add a little bit to that conversation, and that's exactly the way we're moving in a number of projects that we're involved in, but not strictly even necessarily English language. So we're looking, for example, at the linkage between Inupiaq knowledge of sea ice and scientific and operational knowledge of sea ice. And it's interesting because in that case you think, well, it's all sea ice, but ship operators are looking at it a different way than scientists, who are in turn looking at it a different way than users who are actually on it hunting and so on. So that's one aspect of it, and I would sort of highlight there's a technical component of this that, it's being described in terms of the standards and all of that, but there's a community component of this as well, is being able to actually sit down and have these conversations and these dialogues and these processes of developing the ontologies. And that's something that I think within the communities, they need to be part of building this, driving this, because that's where the domain knowledge is, and that's sort of where we're at. And it's really working well in some communities. Other communities, I think they're just sort of starting to learn about the possibilities. So something to think about there. One just last thing as well is we're also thinking about this, and Matt is definitely involved in this, and others at the international level. So we're talking a lot about this, in IARPIC and, what we're doing, but we also have colleagues in Norway and Sweden and Russia who are doing the same types of things. So we're actually working together now on setting up an international working group for polar semantics and vocabularies. And that's mostly just going to be to try and get people together to understand, what's happening, who's doing what where, and so people can know, for example, about the work that's being done under ESIP or under the Arctic Data Center, and don't reinvent the wheel. Because one thing that can happen with these ontologies is that people won't be aware of what other people are doing. So they'll start spinning up, a number of different ontologies, and then you're trying to figure out how you get the ontologies to talk to the ontologies.
So,
can I just reiterate that before you move on, Mark? That the social process of coordinating all of this is probably the biggest challenge. The technical hurdles of how to do it are really kind of bookkeeping decisions, but that it's a very large space. There's a lot of people from not just, as Peter, you very much outlined, there's multiple different domains and communities of practice and local communities and international science communities that all need to kind of be on the same page. And so I think it'll take a long time to build that up, but that doesn't mean we can't get started now in sort of consolidating smaller communities of practice. And the closer together people are, the easier it is to get some sort of, common ground on what the different vocabularies represent. So we think we should start working from the bottom up and keep trying to merge them together, rather than trying to work from the top down and try to build one global vocabulary. Yeah.
Absolutely. Yeah, we're finding that even within communities that might be 30 kilometers from each other, there are differences, there's different cultures and so on. So again, we're just getting moving rather than sitting back and waiting for that Uber model that's going to solve the problems of the world.
So I wanted to bring in Wen and Chris, because you bring in a different perspective for thinking about this. So either one can begin, just where does your work fit in with trying to conduct, let's say in this case, a carbon synthesis in a sort of an applied way? Wen or Chris, where does it really come in where it can make a difference for someone, for us, trying to come out with a synthesis for carbon, Arctic carbon? Either one. Chris or Wen?
Yes,
Sorry.
this is.
Go ahead. Wen. I was on mute. You can go ahead, and then I'll follow.
Okay. I completely agree on what we have discussed so far, because I think a top-down ontology is really, we need to overcome the social issues. So most of my work has been working on developing bottom-up approach, which utilize part of the ontology, like the community ontology we have developed so far, like GCMD, the Global Climate Change Master Directory's science keywords, and as well as suite and other existing ontology to help with the semantic understanding of the data. And another approach, like technical approach that I have been following is how to make understanding of the data semantics from metadata and the data itself automatically. So this is, I think, an area that can help us to build up the bottom-up ontology gradually to support different applications, such as the carbon application we are mentioning for synthesis of different data and with different providers and organizations, etc.
What do you mean by, when you say automatically? I initially start off this with the premise that eventually it all has to be automatic because we'll never do a synthesis otherwise. What do you mean when you say automatic?
Yes, the automated way that I have been following is using some of the machine learning, and more specifically like the deep learning approach that by digging out the data itself in order to extract the semantic from the data and the metadata in order to enhance understanding. So a lot of the challenge we have met is the one is the lack of the good descriptions on the subject of the data in the metadata. The other is, as we have mentioned, different data providers, different scientists, they tend to use a different set of the keywords to describe what the data is about. So I have been trying to identify ways whether we can extract a common semantics from the data using some of the deep learning and the data mining approach to do this automatically. So this is one of the ways that
Okay.
I'm working
Chris, you want to say a word?
Sorry?
Yeah, can everyone hear me?
Yeah.
Great. Yeah, I mean, so for me, like, it seems like there are two potential ways, at least some of the stuff that I'm working on could help out with this. Well, first, you know, whenever you do any of these types of assimilation studies, one of the things you need to do, and when discussed this a little bit, talking about her types of crawling technologies, is, you know, acquire maybe coincident data, you know, related to either temporal or geographic constraints of what you're trying to study, you know, for that. And so at least some of the crawlers and things that I've been working on could potentially help, you know, acquire some of that coincident data, just bulk, you know, in bulk for bulk analysis without having to download a bunch of it yourself and manage that downloading and or, you know, those types of things. At least from a, you know, satellite remote sensing perspective, I know that some of these are field measurements, and then, you know, doing assimilation from that requires a little bit of work. But just in terms of acquiring the data itself, I think it could potentially help. Second, I haven't heard a lot of discussion, but I suspect, you know, being a PhD level researcher myself or whatever, that there's a lot of reading that goes along into understanding some of these studies, just finding associated papers and, you know, things like that, and seeing what your colleagues or potentially your competitors or whatever are working on, or what types of, you know, temporal, geographic, what types of ranges in the spectrum, you know, they're working, things like that. And so some of the stuff that I'm working on could potentially point it at, you know, a domain, you know, like carbon or, you know, carbon in the Arctic and things like that. It could pull down and do bulk analysis on a bunch of the papers with that, tell you who's doing what types of measurements they're taking and things like that. So at least gives you an understanding of how to frame some of your experimentation, you know, in the study and things. So those are two areas at least that I thought of, you know, and of course this is very early on, you know, we have to get into a lot more detail, but those are two things I thought of.
Mm-hmm. So I guess the question then would be, how would we, as a group, if you were taking, you know, a medium and a long-term view, and, you know, maybe medium is 3 to 5 years, and a longer-term view is 5 to 10 years, and you say, well, I'm heading towards developing a budget. and I'm not completely sure always what a budget means um, for the Arctic, but we want to develop a carbon budget. What is it that everybody in this group needs from the others to get it done? I mean, so if you wanted to lay out a plan and you're all working in your areas, clearly Matt would like something from, you know, when things are being reported to the data center, Matt would probably appreciate the data to come in some explicit form.
Yeah, and I can comment on that just briefly. So when we're getting data right now, you know, historically, there hasn't been a lot of metadata in the sort of historical archive that really dealt with the specifics of the measurements that were collected. Metadata was at a much coarser grain. And so we're moving towards a situation where we're trying to have investigators first describe, you know, each of their data tables and geospatial data structures in more detail. And right now we're just trying to get them to, for example, list in their own vocabularies what those are. What we'd like to do is to move towards a system where when people are submitting those data sets for archival, they're also providing those semantic mappings to the vocabularies. And there's a tooling issue there. So in terms of your timescale, Mark, I think, you know, we as a community need to develop the vocabularies so that we can then incorporate those into the tools that scientists use to submit and archive data, so that over the long term, those data are much richer for people to make use of. Right now, I think we have a heterogeneity problem that's tough to deal with over the short term.
So if Christina, let's say, though, wanted to say, okay, what I would like from the data center is something, is it software you would like from them so that you could more easily extract data? Is it, you know, so Christina, if you go into a data center, what if you were going to do this, well, in your case, for terrestrial carbon, what is it that makes your life easier and harder? And what are the kind of things that you would ask a data center to think about?
Yeah, I think what is really useful is if there is a template available and people fill in the template. So we upload quite a few of our data into LTR Bonanza Creek sites onto there. And they do have a template, how you have to fill it in, and you have to explain what each column means, etc. That's really helpful. Still, if anyone uses the data, they still have lots of questions. And I think that's somehow inevitable, but having a template and people stick to the template, I think that really makes things easier.
Is that a practical thing? I mean, I guess, so my question then would be units. I mean, is units still a problem? Is the fact that people aren't providing units? But I can also see, and that this question of derivative, that what is the data? So if you're making a measurement, but you're reporting something else, something that's derived from it, obviously it makes a difference to you. I don't know, so Christina, how does it play out for you when somebody makes, you know, when they go from biomass to carbon, and you say, well, how did you do that? You know,
so I definitely want to know how it was done. If that information is not available, I have to contact the data owner, I think, because I don't want to just use a number on carbon if I don't quite know where it's coming from. So I do think that's really important. And sometimes I had to recalculate because it was done in a way that wasn't consistent with all the other data or not the way I wanted it. And so if you provide everything you have, then whoever uses the data can do different calculations. I do think that's important.
So does that mean people have to, well, one of the questions I had is do we have to be starting to become more NASA-like, where we have level 0, level 1, level 2 data, and within each of those data sets is the software that allows you to decide which which level you want.
Yes, I do think it just creates a lot of extra work for whoever is uploading the data. And so that's why people are a little reluctant to do it. We have also started to include R scripts or calculations. So you give the raw data, you give the modified data, and you provide how you got from A to B. That's useful. It's sometimes hard to understand, but I think it's a good step forward for sure. Yeah.
And we would love that at the Arctic Data Center. We encourage people to upload their scripts along with their data. And we even have mechanisms for directly annotating how a script was used to take an input set of data sets to produce a particular set of output data sets. So we can say these 7 data files were run through this script to produce this derived file. And then that derived file was in turn run through a different script to produce, say, two outcomes, like maybe a carbon visualization or a map. And so we can link those things together in a way that's really easy to see if we have the information. But so what we don't have is good tooling for people to submit that information right now. But if they just provide it in English narrative as they're doing it, we can add that information into the published data packages. And as we develop tooling, it'll get easier and easier for people to submit that as they're submitting their data sets.
I think the time commitment for uploading data is pretty big, and sometimes it's like, where's the benefit? Whereas if you write your paper and you submit it, that really counts a lot. I do think we need to take that into account as well, make it as easy as possible, because it's not happening otherwise. I think it's a big good thing that I'm dealing with, at least.
When you say not happening, well, to some extent, NSF is really changing in that we are, in one way or another, forcing PIs to submit their data. And I think the data center has been pretty rigorous in enforcing standards for that data submission. So hopefully that's changing. Hopefully that aspect of just publishing without submitting is sort of ending. So Jim or
Mark, yeah, I have a sort of follow-up comment on what you were just saying. So yes, we've been urged to get data posted quicker and quicker, and in general, I'm not against that. But one of the downsides to that is that some of these derived products that were mentioned earlier, those don't get posted then, because you're just shooting up essentially the raw data, right? Because that's what fulfills your requirement to NSF to get that darn stuff up quickly. And at least I'll use what I'm most familiar with again, sort of say riverine fluxes to the ocean. There's lots of ocean end member user people that are interested in these inputs from an end member perspective, right? So I can throw up concentrations from rivers all over the Arctic, and someone can go get river discharge data from somewhere and do some calculation of that flux. Yeah. But the awful things that people do when calculating those fluxes, when it's not their area of expertise, is really hard to watch. And all these numbers keep coming out, and all these numbers are different. And it's 99% of it has to do with the way that people are using or misusing the data to do calculations that they don't really appreciate or understand. And so the end products, these derived products, are as important, and some contexts more important than the original data, right?
Well, let me make 2 comments on that, because one I want to make a comment on, and then the second I want to ask Matt about. The comment one is, so I'm here on a certain basis, and then I go back to my university, so I know both sides of the data, and I can tell you the reality of the data. Here's the reality of any project. A project is 3 years long. After the 3rd year, there is a no-cost extension by the university. After the next year is another no-cost extension. And I would say 100% of the people use those. So, and people are then reluctant to provide their data unless you really, really bother them. So that is a 5-year period. Now, if the argument is made that in 5 years you can't deliver the data, there's something inherently wrong because you wrote a 3-year proposal. Now, as far as the derivative data, I absolutely agree with you that many cases the derivative data is the most important data. Now, the one issue with the derivative data is once a project is over, it's over. Most people do not have the desire to spend the days to go back into the data center and provide the derivative data. However, if you do want to provide the derivative data, maybe Matt can say a word because they do have a version controlling for the derivative data. And Matt, maybe you could say a word about that.
Yeah, absolutely. I mean, we very much encourage people to deposit the results of integrative and synthetic activities that produce higher level data products. Those are the most useful things to the science community, and they represent a jumping off point for other researchers to build further on the work without having to do a lot of the original data processing that the original project did. Of course, there's also things like people change their minds. The community sort of shifts as they you do some data processing, and then you realize atmospheric correction algorithms get better over time. You want to reprocess that data to produce a new product. And when you do that, of course, you need the original raw data to do that. So I don't think that there's any way around archiving both types of products. And really what I think the community would most benefit from is doing so in a way that links them together so you can understand the relationships between them. Right now, the archives that are out there have a mix of those primary and secondary data sources. It's really hard to tell them apart. It's really hard to tell which ones are overlapping and which ones are not. And that's something we're trying to change. I don't know if I can share my screen, but I have a kind of a screenshot showing a data set, kind of how we'd like to see things arranged. It does take more time, and I'm real sensitive to Christina's statements about how much time it takes, and it takes out, it takes away from the time you have to spend with other parts of the scientific process. But so this is a data set that you can see on my screen that's in data 1. It came from AOS up in Alaska. It's a hydrocarbon data set that basically looks at lingering oil from the in the Prince William Sound. It spans several decades, and so it's a really useful synthetic data set. And in it there's a whole bunch of different files, and it's the raw data files, but also the R scripts that were used for collecting it. And this kind of list of files like this is usually the most you get out of people. But what we want to do is get to the point where if you go down here and look at this section, this thing we're looking at in the middle here is kind of an integrated derived data set that they published. That's the total alkenes for the Prince William Sound. And it came from 4 source data sets. So I can look at each of these and see exactly which data set it came from. And then I can look at this and see this is the script that took those 4 data sets and combined them together to make this derived one. And then in addition, this whole derived data set was used by this script over here to produce these 2 maps that were also archived with the data set. And I think this kind of a layout really makes it so much clearer to people what all the products are and how they all relate to one another, so that scientists can know, if I want to use this derived data, it really depends upon these primary data, and they aren't overlapping. And we're just not capturing this kind of information on a broad scale yet, and we need to be.
Matt, could I ask something of you?
Sure.
Maybe it will take, I don't know, in a couple of hours or whatever it is. Is it possible for you to take this and put it on the IARPIC website for people to see as a model?
What's this? You mean like this website?
Well, yeah, that's what I'm trying to figure out right this minute. I'm looking at what you're showing me, and I think most people haven't seen this before.
Yeah.
And so it's very neat, and it makes you think about what can be done. And I wouldn't even know how you did that. It's like, to me, I'm looking at the left and I'm going, wow, that's pretty neat. And is that just, you know, a schematic, or is it real? And how was it constructed?
Yeah, so this one's, it's another one of these vocabularies for representing the relationships among things. And we painstakingly are the members of the data team here, you know, basically sleuthed out this information and added it to this data set. And we're trying to build tools that make it easier for people to add that as they submit data sets. Right now, it's still largely a manual process. The community writ large isn't collecting this, and scientists that are working with their data aren't even necessarily keeping this information close at hand in their own management. You get a lot of data sets that are, you know, there's sort of a lot of data processing that's going on, and everything's kind of in one folder structure, but it's not always really clear from just in the materials that were sent what that is. So sometimes it takes lots of back and forth with the researchers to understand what their units are on every data file, and then for each one of those units, you know, what the semantic type of each variable is, and then how each of the different data files was used by processing scripts. And so right now that's a dialogue, and we need to get to the point where that whole capture process is more automated.
So what you're showing on the screen here, is this something that's available currently? Is this something that's automated, or is everything on the left really just to show in a figurative way, or is it really part of an operation here?
It is part of an operation, and we have tools in R and MATLAB for generating those relationships. So there's a learning curve associated with that. What we're trying to do right now is we're working on a web-based tool as people do submissions for people to, so basically over here, there would be a little plus button where somebody could click and add another source data set that led to this. So basically for people to link things together through the web view of a data set that they've submitted. And we're not there yet. And that will hopefully come out in the next 6 months or so as part of our tool chain. There's lots of people working on this. And like I said, it's kind of a social problem trying to coordinate and get everybody to agree on a way to do it. There's lots of ways you could do these things. This is one such system. There are others in the works. And getting that agreement, just like in the vocabulary case, is where I think a lot of this falls down. It's not that if we could all just magically agree on how to do something, all of a sudden, then technically doing it's not that hard. But there's a lot of social work in getting all the different repositories and centers to kind of agree on what to do. So it'll take a while.
So just to close
we're really willing to work with people, you know, on a one-off basis to get this information captured.
Just to close off, maybe if anybody really can say a few words, okay, this is something we're heading towards a carbon synthesis. This is what I think we ought to do, or if all of you in a room, this is what you'd sort of like go after. Maybe just a word or so of how do you think we should move forward? Jim, or?
Well, yeah, I'm happy to. So I think that the vocabulary discussion that we had is a definitely a valuable one, but it also sounds like a lot of progress is being made there. So sort of keeping after that is good. I mean, there are other, of course, besides the vocabulary sort of theme that we're focused on today, there are other barriers to synthesis, and we're ultimately going to have to pull in some of, you know, have a broader discussion about those. One, of course, has to do with time and money. And another has to do with scale, and it's and maybe in some ways it gets back to the vocabulary things. What's big to one in one context is small in another. What you choose, what's important to include from one person's or one discipline's perspective, and what's important to not bother including, I guess, in another depends a lot on discipline and also scale, and depending on how integrated a synthesis you're trying to do, you have to break down those those barriers that are related to scale, and have the people that are working at a really big scale recognize the importance of the stuff that's going on at really small scales, and in a way vice versa. So yeah, those are my parting comments anyway.
Okay, Christina?
So I think we actually lost Christina. We're getting a little bit over on time.
I know. All right. Maybe what we'll do is we'll close it down now.
And if anyone has any comments that you'd like to contribute to wrap up kind of like what Mark was asking, a good way to do that, and the way we've done that in the past, is if you want to go to the event page for this call, which I'll include in the chat box right now, you can comment on the website. There's a space at the bottom of the page that you can add a comment and tag someone, or just kind of contribute anything that you'd like to include in the notes.
Yeah, I'll go do that afterwards, Emily, thanks. But one thing I would say is that what really encourages me about this call is getting a group of information management people together, working with a group of scientists that have a shared set of goals and trying to figure out how to make incremental progress. I think the hardest part for us has always been finding time to interact with the very busy scientists' lives. It's complicated, and it's, you know, everybody has a lot to do, and trying to find a group of people that are willing to help prototype out these things and figure out what works is really helpful. So if this group can just do that, then that's, I think, will help move things forward a lot.
And piggybacking off of that, one thing I wanted to mention before we wrapped up is that environmental intelligence is trying to do just that, is getting modelers, observers, and data managers into having these kind of conversations. And we're going to have our first forum, which is on Monday, the 31st, from 2:30 to 4:30. There's an event page. I'll send out a reminder to everybody that's on this call to see if you can join in. It should be another similar kind of discussion, again, framed around the carbon question of how to get those different groups integrated together. So thanks for that segue.
All right. Well, I'll just say thank you for everybody coming. I know everybody's busy. So this was great. And if you do have comments, go to the site, leave your thoughts there, and we'll talk about this again soon, I'm sure.
All right. Thanks, everybody.
Great meeting, everybody. Thank you.
Okay. Night or day, whatever.